Welcome to This Explainer. Today, we're diving straight into one of the absolute most frustrating, costly, and frankly, kind of mysterious headaches in modern manufacturing. We are talking about the ultimate pump assembly nightmare. You know the drill. You've machined your parts perfectly, you checked all the tolerances, everything looks totally flawless on paper, and yet things still go completely wrong out on the floor. Well, we're going to break down exactly why this happens and how industry veterans like Jarvis cutting tools actually solve it. Okay, let's jump in.
Seriously, if you're in manufacturing, engineering, or maintenance, I guarantee you've felt the pain of this exact scenario. How many times have you seen a threaded joint absolutely ace its inspection, hitting every required spec, only to immediately start leaking the second you fire up the pump? It is this universal, high-stakes pain point, and it ends up costing facilities massive amounts of time and money in rework. And this really hits at the core of what we're looking at today. Kostick Jarvis, the fifth-generation president of Jarvis Cutting Tools, points out something so fundamental here. Standard compliance just isn't the whole story. Tapered threads in pump systems rarely fail because someone forgot to follow the standard, right? They fail because there is a massive, massive gap between a part being measured right on a nice, clean, static workbench and that same part actually working right inside a vibrating active machine. It really comes down to the stark contrast between static and dynamic environments. Static sealing, that's the peaceful, controlled world of gauges and standards. It's safe. Dynamic sealing, on the other hand, is the violent, active reality of a working pump. We are talking about intense pressure, moving fluids, relentless mechanical cycles. A static gauge simply cannot tell you how some tiny geometric deviation is going to behave once that joint is thrown into dynamic chaos.
All right, let's look at Section 1, Hidden Geometry Under Pressure.
So, the crucial thing to understand here is our first two culprits, pitch and taper. Now, most shops will immediately check the taper angle, but honestly, pitch diameter actually carries way more weight in practice. A slight drift in pitch diameter literally moves the sealing zone along the thread. Inside a pump, that means your joint might be relying on a really weak, partial contact area to hold back immense pressure. Plus, a minor taper angle deviation, it doesn't just stay minor. It builds up over the length of the thread, shifting the load and creating these dangerous weak zones that you basically can't even see with the naked eye. And all of this builds into a totally predictable cycle of failure. Think about it. Pumps introduce a repeated rise and drop in pressure. Step 1, you start with that minor angular deviation we just talked about. Step 2, this creates uneven load distribution instead of a nice, continuous seal. Step 3, the cyclic pressure shifts from the pump start acting like a hammer on this uneven joint. And finally, Step 4, those repeated shifts permanently deform the contact band, breaking it into segments and opening up micro gaps. Boom. Just like that, you've got a leak.
It's a super delicate balancing act when we talk about crest and root geometry. A lot of the time, crest truncation is just treated as a little tolerance box you check off on an inspection sheet. But doing that completely destroys your sealing stability. Too much truncation, you reduce your effective contact area. Too little, you get this aggressive interference that physically damages the flanks the second you tighten the joint. Oh, and we definitely can't forget root clearance. If you have poor clearance, the fine debris carried by the fluid is going to get trapped, acting like gravel and causing severe localized wear.
Moving right along to Section 2, Fluids, Friction, and Finish.
Let's just bust a massive manufacturing myth right now. Surface finish is not a beauty contest. I repeat, a shiny, visually perfect finish does absolutely not automatically equal a better seal. In the world of dynamic pump sealing, the surface finish is a functional, physical landscape. It's full of microscopic peaks and valleys that directly interact with whatever fluid is flowing over it. You absolutely have to understand your specific fluid here. Low viscosity fluids are incredibly sneaky. They will find microscopic paths right through your fine machining marks. Viscous media, on the other hand, act completely differently. They might actually mask minor imperfections at first, giving you this false sense of security before failing catastrophically down the line. Also, the direction of your finish lay matters immensely. If your machining marks line up with the leak path, congrats, you just built a microscopic highway for the fluid to escape. And then fluid chemistry introduces a whole new set of threats that will degrade even the most perfectly machined threads. Corrosive fluids will literally eat away at your sealing surfaces over time. Abrasive media act like liquid sandpaper, constantly wearing down the thread flanks. Your machining decisions have to anticipate what is actually going to flow through this system, not just the initial dry fit. And the ironic part, If you try to outsmart this by making the finish incredibly smooth, you actually drastically increase the risk of galling during assembly.
Which brings us to Section 3, Assembly and Torque Realities.
So when you tighten a thread, the seal isn't purely about geometry anymore. It's about material behavior. A certain amount of elastic deformation is actually great. It helps the metals conform and get that tight seal. But if you push it too far into plastic deformation, you permanently alter the thread. In pump systems that require frequent opening and reassembling for maintenance, this is a total disaster. A joint that's sealed perfectly the first time will literally never seal the same way again once it's plastically deformed.
Now let's talk about every maintenance team's worst nightmare: galling. Basically, this is the sudden seizure of threads during high-torque tightening. Since pump maintenance cycles are so frequent, threads see a ton of repeated tightening. If your material pairing involves similar hardness levels, the risk of the metals cold welding and tearing, which is what galling is, just skyrockets. Once it starts, the surface integrity is instantly destroyed. And the really tragic part? It almost always gets misdiagnosed as poor machining, when it's really an assembly and material choice issue.
All of this stuff combined leads to an incredibly frustrating chain reaction on the assembly floor. It starts with just a slight misalignment during assembly, which creates uneven loading. Under pressure, segmented contact forms. And because the geometry is drifted, the optimal torque window becomes totally unpredictable. So what happens? Operators feel the joint is unreliable, and, human nature takes over. They compensate by grabbing a bigger wrench and just over-tightening the whole thing, which just accelerates the damage, leading right back to leaks and galling.
Let's dive into Section 4, the Jarvis cutting edge. 1901. Just think about that year for a second. That is the year Jarvis Cutting Tools was founded. That is well over a century of deep, evolving legacy as a family-owned manufacturer. When we talk about solving these insane, complex, dynamic sailing issues, we really have to look at the benchmark. Jarvis isn't just making tools. They possess this generational understanding of exactly how metal behaves under extreme pressure and wear.
But behind all that history is highly focused, totally modern expertise. 35. That represents the 35 years of dedicated, hands-on shop floor, engineering, and operational experience brought by the current fifth-generation president, Costigan Jarvis. We're not talking about theoretical knowledge formulated in a boardroom here. This is hard-earned insight, sourced straight from the manufacturing floor, dealing day in and day out with the exact pump thread mysteries we've been uncovering.
So what does this actually mean for you? Well, it's the Jarvis advantage. As the largest privately owned tap manufacturer in North America, they don't just sell tools off a shelf. They create massive value by designing, manufacturing, and servicing products for standard, special, and highly material-specific applications. Because they've spent literally decades specifically solving the real-world pressure and cyclic thread behaviors that cause standard tools to fail, they are uniquely equipped to overcome these dynamic sealing failures. And that brings us right back to our core thesis, which Costigan Jarvis summed up perfectly. Machining has to account for pressure, fluid, and repeated use. True standard compliance isn't just about passing a gauge test on day one. It requires actively anticipating the aggressive, dynamic environment of the working pump and engineering your tools and processes to actually survive it. So, I'm going to leave you with one final provocative thought to chew on. Take a close look at your own operations. Is your machining accounting merely for the static gauge sitting comfortably on a bench? Or is it engineered for the violent, dynamic fluid flowing through the system under pressure? Because understanding that difference, that is exactly what separates a constantly leaking pump from a totally flawless operation. Thanks so much for joining me on this explainer. I really hope it helps you rethink your approach to thread machining.